want today. Let's see.
Hello, sir.
What up, baby?
I'm good, and you?
I'm doing okay. What's up?
Yeah, Ish. May you please help me with a mathematics?
Can I please help you with the mathematics?
Yeah,
What mathematics?
grade 9.
What part of the mathematics in grade 9?
Solve for X.
Do you have a problem that you want to?
Yeah, it's challenging me.
Solve for X is challenging you.
Yeah, but not much.
So do you have a specific problem that you have in front of you that you want to look at?
Yeah, Ish. Like, give me 2 minutes. I will show you
Okay.
the problem.
Okay. M key star. I need an assistant. You need an assistant. Some people need an assistant, eh? Wow, guys. Njaka, solve for X, it's about transposing. Kutlwano Tebe.
Good evening, sir.
Yeah, MK Star, what's up?
How are you, sir?
I'm okay, and you?
I have a problem
What's the
with the
problem?
topic hyperbola.
With
I
the
need an
topic,
assistant on the grade 10 topic hyperbola.
the grade 10 topic hyperbola. So you mean the hyperbola function? Eh? Mr. MK Star,
Eh?
you are saying you have a problem with
Yes, sir.
hyperbola.
Yes, so I need an assistant.
So what is it about the hyperbola that's a problem? Do you mean the entire thing is a problem?
Yes, sir, solving it is a problem. Some I can, some I cannot. When it comes to the graphs,
Yes. Do you have a specific image that's in front of you that you want to look at?
yes, sir.
Okay. So I think we'll look at these things in the order. I just want to check if Pepe has found his problem and is ready to tell me what it is specifically, and then we'll look at yours as well. So if you can just for a moment
Yes,
be
sir,
muted, I'll be with you now. Pepe. Mr.
I'm back.
Yes. So yeah, what's the problem? Do you have a problem in front of you?
Yeah.
Okay, what does it read? What does it say?
The question says, solve the following by substitution where x is equals to 3 and y is equals to -4. And A says 2x.
Okay, so basically this is a substitution problem. It's not a solve for x. Okay, but anyways, let's look at it first. You said it says solve for x. Okay, it says what?
Solve the following by substitution where x is equals to 3 and y is equals to -4.
Okay, what is the expression or the equation that you have in front of you?
A 2xy
2xy
minus 3y to the power of 2
minus 3y to the power of 2
plus square root 4x minus.
Okay, so plus square root is everything else under the square root.
Yeah, 4x minus y.
Is that all under the square root?
Yeah.
Okay. All right. Is that the first problem?
Yes.
Okay, what's the second one? Is there others that follow that one?
Yes, I have 1, 2, 3, 4.
How many are there?
5.
There are 5 of them.
Yes.
All right. So the other 5, the other 4, you will do them, but this one I will just show you.
Yes.
Okay. So you are told to solve this. Okay. We refer to this as an expression. In mathematical terms, this is an expression. Okay.
Yes.
Are you with me? Yes.
Yes.
So in this expression, an expression can have one or more terms, okay? And an expression is separated. If it has more than one term, then it means that that expression is separated by a plus or a minus sign. In other words, expressions have what we call separators. So you see this minus sign, this first one?
Yes.
And you see this plus sign?
Yes.
Yes, it separates these terms. So in this expression, we have 1, 2, 3 terms in total. All right? Okay.
Yes.
So basically now what you are being asked here is to solve this, is to actually get the value of this expression if x is equal to 3 and y is equal to -4. Hence I said these questions are substitution questions. So you have to now go to the expression, identify where x is, and you will substitute, where x is, you'll substitute 3, and where y is, you'll substitute -4.
Yes.
And when you do that, you are going to use brackets when you substitute in the respective letters. Are you with me?
Yes.
So this is what I'm going to do. 2 into, you see this x, I'm going to substitute who?
3.
And then in the place of y, I'm going to substitute who?
-4.
Yeah, all right. Minus 3 in the place of y.
-4.
And then plus square root in the place of x.
3.
And then minus in the place of y.
-4.
Exactly, bro. Okay. And you see, everywhere I'm substituting, what am I using? I am using brackets.
Yes.
Now, you can see that for my first term, 2xy, I now have 2, and the relationship that exists between the 2 and the x and the y was initially multiplication. This is what combines the 2 and the x and the y. It's multiply. So that's why, for instance, when you come here, you have 2 times 3 times -4. Are you with me?
Yes.
Yeah. Then let's leave that one. We have minus here, 3. But then in brackets, we have -4 and we have the exponent 2.
Yes.
Okay? Plus a square root of 4 times 3, because brackets mean multiply,
Yes.
minus brackets minus 4. So once again, we have multiplication of signs that we would have to resolve here. So just before you jump in and solve, when you are simplifying this expression, you need to remember this guy.
Bird mass.
Yeah. Me, I tend to say bed mass. You know?
Oh,
Very soon you are going to go to bed. Are you looking forward to that?
like why it is bird mass? No, I know bird mass.
Let me ask you, you said board mass, right? So I want you
Yes.
to tell me, what do the individual letters stand for? B, what does B stand for?
Brackets.
Brackets. Okay, now I'm going to say this side brackets because my B also stands for bracket. What does the O stand for?
Off.
Off. How do you spell that?
O double F.
O double F. And what does this even mean, this off? Can you tell me?
Like it's when you are rounding off.
Oh, rounding off. Wow, okay. D?
Division.
Who's speaking there in the background?
My brother.
Oh, your brother. What grade is your brother doing?
10.
Grade 10. Oh, hey, when you are fortunate, more. So you are in grade 9.
Yes.
Your brother is in grade 10.
Yes.
And your brother does pure maths.
Yes.
So why isn't your brother helping you?
Hi.
Hey, mfanaka.
Akati school umtu.
Karate isikolo.
Yeah.
Mfanaka. Okay, then the A, addition. M,
Yes,
multiplication. Is that what you were going to say, right?
Yes.
The S,
Subtract.
subtraction. All right. Now, there in the comment section, there's someone who is saying your off is supposed to be off. That's what the person in the comment section is saying. Is he right? Is she or he right, or what?
Yeah, he is right.
Oh, okay. Amen. All right. No, that's fine.
Yeah,
now let's
thank
come
you for
here. You were
helping
asking
there.
me, what does the E stand for? The E stands for exponents.
Exponents. Oh, yeah.
All right, Mfanak?
Yeah, right.
Okay, I can. My letter, everything else, DMAS, you know, but it was
Yes.
just the E, right?
Yeah.
Now, what is this board of bed mess all about? It's about the order in which we are able to simplify an expression with many aspects to it, like brackets, exponents, division, multiplication, addition, and subtraction. We don't just start at the bottom here with subtraction. No, we always start with brackets. Our order is important. If the order is not followed, Pepe, we actually stand the risk of losing the plot.
Yeah.
So I'm going to come back here now and I'm going to observe bed mess. I'm going to observe bed mess right now. So look here, you have 2, you have 3, you have -4. This is you remember, like I said, this is a separate term. All right?
Yes.
It's separated by this minus sign. Then you have another term separated by a plus sign.
Yes.
Then you have another term. Are you with me, baby?
Yes.
Now listen very well. It means when I come to this term, I can just look here and say, all right, BEDMAS. What do we have here?
Bracket.
Exactly,
Yes.
amen. So that
Yes.
means we can attack here, all right?
Yes.
We can attack immediately. But these brackets here, they have meaning, all right?
Yes.
It has nothing to do with the exponents. It has nothing to do with division. It has everything to do with who?
Multiplication.
Amen. Let's go. What's 2 times 3 times minus 4? 2 times 3
6
times minus 4?
times minus 4.
Yeah.
Can I use a calculator?
Mfanaka. All right, go ahead. You should know these things, man. Your head should be popping multiplication.
Ish.
Mfanaka.
Like 2. So 2 times.
I'm waiting, Mfanaka. 2 times 3 is 6. 6 times negative 4 is? A positive times a negative gives you a negative. And what's 6 times 4?
Then Ish.
I've helped you out there. It's negative 4.
Yes.
Okay, Mfanaka. Okay, let's move on. So this term is sorted. Now let's go to the second term. You see the second term has minus 3. There's the bracket. There's minus 4 inside. And then there's the exponent. So now I go back again to what? To bedmass.
Yeah.
Brackets, I have brackets. Exponents, exponent. I need to apply the exponent to the bracket.
Okay.
But the minus 3 needs to hold itself for now. So I'm going to write down minus 3. And then I'm going to sort out what's happening in this bracket. If I apply the exponent to this number inside the bracket, okay, I apply the exponent 2 to the negative sign. If I apply an even exponent to a negative sign, what happens to the negative sign?
It's change. It's going to be
to what?
Positive.
Thank you. And then what's 4 squared?
8. Yeah, 8.
Be careful. 4 squared is the same thing as 4 times 4, which is?
16.
Yo, Mfanaka. If you say 4 squared is equal to 8, then in your head, when you are interpreting this to mean 4 times 2, which is 8, which is absolute.
Yeah, I'm thinking about that one.
Yeah, Mfanaka. No, Mfanaka. That's not how we interpret this. 4 squared, remember, this means how many times do we repeat 4?
Oh.
Are you with me? This is repetition. So if you have 4 to the power 3, it means I'm going to write how many 4s? 1, 2, 3, 4, multiply to each other. If I have 4 to the power 4, it means I'm going to write how many 4s multiplied together? You see, it's not 4 times this. No. That's no, Mfanaka. No. This is not how we think of it. Are you with me?
Yes.
Yeah. So as you said, when you apply the exponent to the negative sign, it leaves you with a positive. If you apply the exponent to the 4, then we have a positive 16. So I'm very safe in writing what? Positive 16. Are you with me?
Yes.
Do we have any questions about this? What
yes,
I've just done?
Why are you putting the bracket? So we are going to multiply negative 3 multiplied by 16.
Are you telling me or are you asking me?
I'm asking.
Change your question to a statement.
It's like
you just asked, are we going to multiply the negative 3 to the 16? That's what you are asking me. Now I'm saying just change that question you are asking me and state it as if you know what you are saying.
Oh, like ish.
Like you have to.
Oh, okay. Let me do like this.
Yes, Pepe. We are going to multiply. You're saying, why am I still keeping the bracket there? Remember,
Yes.
I'm keeping the bracket there because this 3 has a relationship with 16 of multiply. Okay?
Oh, yeah.
So that's why I'm keeping it, because I'm going to eventually multiply this negative 3 with the?
With 16.
Yes, I'm going to do that. All right? Yeah. But for now, let's move. I'm going to come back to this in the next step. Are you with me?
Yes.
Okay, let's go here. The next term. This is the next term, right?
Yes.
Okay. So the next term here, what do we have there? A square root, all right? And we have 4, we have a 3, which is 4 times 3, and then we have a negative sign and a negative sign in brackets and 4. So that means we can go back to BEDMAS, brackets. Let's sort out what's brackets there. We can do that. What's 4 times 3?
12.
12, Mfanak. What's negative times a negative 4?
Positive.
Positive 4.
Yeah.
Okay, Fanaka, it seems like we are getting somewhere. Can you see?
Yes, sir.
Yeah. Next step. Negative 24. Now you can tell me what's negative 3 times 16. Yes, you can use your calculator. I'm just going to, sort of like help you there. A negative times a positive is a negative. 3 times 16 is 48. Okay? Are we together still?
Yes, sir.
Plus, now, the square root. What's 12 plus 4?
16.
What is the square root of 16?
4.
Thank you. So we have minus 24 minus 48 plus 4.
4.
I'm sure now you can see we have only addition and subtraction, so we can add and subtract that and get the answer. Surely you can get it, my friend. I don't think I need to help you any further.
Yeah.
So what does this need, Pepe? What this needs, it needs you to first and foremost substitute the given variable with its number in the right place. Using what? We use brackets deliberately because brackets, they will help us, you see.
To find the answer.
Then we also need to be aware of the number of terms we have. The fact that the plus and minus sign, you remember I said to you the plus and minus sign, they separate the terms.
Yes. Like
What, do you have a question?
I didn't hear you. May you please repeat?
No. I was just saying the plus and the minus, they separate the terms, okay?
Oh.
And then after that, you make sure you substitute the x and the y, the values using brackets. And then you just apply BEDMAS. For each individual term, you apply BEDMAS fully and completely in the order. Someone, I think in the comment section, was asking me, why here in this step did I decide to apply the exponent, but we are supposed to start with brackets? Remember, I come here, I see there's a bracket, all right?
Yes.
But it's negative 4, the bracket itself. In the bracket, there's negative 4. So then what's the next thing I need to look at after brackets? Because, I can't do anything with the bracket at the moment, but I can see there's a what? An exponent. So I go ahead and I apply my next thing, which is I apply the exponent to the bracket. So that's why I got positive 16. All right?
Yes.
Yeah. And then, as you had asked, why am I still keeping the bracket? Remember, negative 3 has a relationship with this of multiplication. And brackets mean, in this case, what? Multiplication, which would be the next thing that I will do for that term, so that I get negative 48. You see?
Yes.
Yeah. And then you come here, it's another term. We still look at BEDMAS. So for each individual term that is separated, we are applying BODMAS or BEDMAS.
Yeah.
Bed more than board. You're gonna go sleep very soon. So you need to lie on a what? On a bed. Hopefully it is not a mess. Are you with me?
Yes.
Yeah. Yeah, Mfanaka. And then get your answer there at the end. I'm sure you have the answer for me. I will not, I'm sure we wouldn't make a mistake here, And yeah. I don't know if there's any other questions that you have.
No,
Yeah. So the rest of those questions that you have there, you will actually do them because you've seen the method that we apply when doing these questions, right?
yeah.
All right. Hi, Kepepe. It was
Thank you.
good. You are a very brave young man. That I opened my life and you immediately requested. You are in grade 9. You have a lot of courage. So you must
Yeah.
always retain that sort of courage. It is good. And when you are lost about something, you should always ask so that you get clarity. Maths is for those who are brave. Those
Can I have
who don't ask, they will have problems. Yes?
Can I have your WhatsApp number?
Can you have my WhatsApp number? You
Yeah,
can inbox me my letter. I will not declare it for the masses just publicly like this. Just send me a message DM, and then I'll give it to you in private. Yes, because my WhatsApp number it entails other things, So it obviously would then maybe you can even notify those who are very those who oversee you at home, your guardians, and let them know, because I wouldn't want to actually do that. You are a minor, so you must tell your parents, Mom, Dad, there's this particular individual na on TikTok helping with this, so that that thing can happen with the overseeing hand of your beloved parents. Does that make sense?
yes.
Yes, my man. Otherwise, you are welcome.
Thank you.
Sure. All right. Now, my good, this guy, he left, the one who was asking about hyperbola, unfortunately. What is this energy engineer high voltage studies? This guy, funny stuff. All right. Yeah, I guess. And Natalia, do I do private tutoring? Yeah, I do. In fact, most definitely. Natalia, you were in my live a few days ago, right? You were in my live grade 11, grade 12? Is it grade 12? No, not a problem. I think your manners are well, they are well, what? The energy engineer, start simple. Maybe you can explain yourself. What do you mean by that? The energy engineer saying start simple. Start simple with what, my good friend? What exactly are you referring to? What are you pointing to in reference to what? All right. Yeah, in the absence, it's just a pity that grade 10 young man, no, Apio, I was just assisting a particular learner because, particular learner had a question, which was grade 9 related, so ended up addressing that. So it was just a matter of me assisting where the need was burning for assistance. So I think energy engineer is actually my leader. I don't know what in the world. Who are you and why are you lingering in my life with these comments of yours? What's happening? What is happening? And you are playing the monkey hide face game as well, which makes me very, very skeptical. Natalia, you said you were I was upgrading. You were upgrading. So what? Aren't you upgrading anymore? Or are you done with the upgrading? Awaiting results or what? What's happening there in the field of upgrades. Okay. Depending on the grade, or you are upgrading currently. Okay, nice. You are upgrading. Guys, I guess I can open this up. Is there something in particular that people would like grade, and a particular topic? We can look at some exam questions related to that. Is there anything else specifically? Oh, nice. You are upgrading. That's cool. Okay. Fun in the sun, hey? Hopefully you're having fun in the sun with the upgrading. Oh yeah, I was doing geometry grade 11 the last time, hey? Grade 11 geometry, I think it was. Okay, maybe we can pounce into that. Trig functions, Eva's column. What grade, Eva, are you in? Because I need to be, it's maybe just a bit grade specific if you're referring to trig functions. Or grade 10. Grade 10 trig functions, romantic though. Let's see if I can't find an exam question here. Yeah, hopefully the sketching of a trig function in grade 10 shouldn't be a pain though, because that's like basically the basis of trig functions for grade 10 is that you need to know how to sketch, and then A, and Q for grade 10s are very important. So let's look at some grade 10 functions. So I'm going to look at these. Hopefully you know these, Eva. Y is equal to cos x, y is equal to tan x. Trigonometry for my brother. Okay, so let's look at just a few, and then let's see if I can't find some exam type questions after that. Just gonna have to see, because the thing is, it's taking a trajectory that I was not planning on taking. Let's see, Eva's Koloma, is your brother saying the whole of trig, or is just like trig functions only, or is it the whole of trig? Because just ask your brother what specifically in the trig does your brother want to look at. Is it trig in its entirety, or is it also just trig functions? Sorry guys, let me just, I think my bob needs a bit of a wipe. Yeah. So let's look at what I call the mothers. Okay. Yeah. The energy engineer, I'm sorry, brother. I think I'm going to let you go. You are actually, this is just, I don't know, part of you is, I don't know, rubbing me up the wrong sort of like thingamabob. So I think I need to let you go while it's still early. Yeah, we call these guys the mothers, right? You guys need to know the mothers. So hopefully we know the mother graphs for sine, cos, and tan. And so for instance, your calculators should be able to assist us here very quickly, but also not only your calculator, you should know this off by heart. Okay, so let's just say 90, 180, 270, and then of course our beautiful 360. So the sine graph, very nice. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is -1, and sine 360 is 0. So this is what we call the mother graph of the sine graph. This is mother, mama, you know, first few words of a child. mama. And of course, I mean, some people would probably even dare to say, well, you could sketch this function and show it even for the negative angles, negative 90, negative 180, negative 270, negative 360, and so it goes, I mean, we could be able to show the picture that this function has. Now, for your mother sine graph, you need to know this shape, okay? The fact that it leaves 0, goes to 1, where 90 is x, goes to 0, goes to negative 1, back to 360, all right? So a complete wave cycle of the sine graph takes 360 degrees to complete, one full cycle. So there's a few concepts that we look at when we're talking about the full complete cycle of a function of the sine graph. So starting from 0 to 90 to 180 to 270 to 360, we could say that a full cycle of the sine graph takes how many degrees? 360 degrees. So we call that the period. Okay. Now, guys, the word period can be used in different contexts, just the word itself. Okay. You will know that a full stop is referred to a period, the end of a sentence. All right. When you are at school, you have something called a period. All right. And depending on the school or depending on the day, a single period will take a certain number of minutes. All right. So there's that. Girls will tell you that they have periods every, call it what you want. So this is the word period being used under different contexts, or different situations. But in this situation, we are talking about a complete, full cycle, okay, of a graph. Okay. So one complete full cycle of the sine graph, okay? So from 0 all the way to 360, a full cycle. This is like a complete wave. I think you guys in physical science do waves, and so you could talk about a one complete wave cycle, okay, in this situation. This would be one wave, two waves, three waves, all right? So every 360 degrees, this pattern or this cycle repeats itself every 360 degrees, every 360 degrees. So the period of the sine graph is 360 degrees because it takes 360 degrees for us to complete one full cycle of that graph. I hope that makes sense to you guys. So we look at the concept of period. Then we also talk about the concept of amplitude. All right. What is the amplitude? All right. If you're looking at the trigonometric graph, what is amplitude? Amplitude is basically the distance from the position of rest, all right, to the maximum. All right. So there's a formula that we use, and this formula that we use is basically half the maximum minus the minimum. So it's basically half the distance between the maximum and the minimum. So hence I was saying that amplitude is simply the distance from the position of rest to the maximum. And if you were to measure the position of rest, from the position of rest to the maximum in this sine graph is basically how many units up? It is 1 unit up, all right? So that is what we refer to as the amplitude. So like I said, there's a formula that we can also use as well. I know sometimes in some textbooks it says max minus min, and you divide it by 2. But I mean, if you're saying half the maximum minus the minimum, it's the same thing as saying maximum minus minimum divided by 2. So this is how we are able to calculate the amplitude. And amplitude is the distance. So there is no way when you are measuring some distance, you will say the distance is negative. No, the distance will always be a positive value. All right. So that is amplitude. So in this case of the sine graph, the mother sine graph, the amplitude would simply be, if we calculated it, half the maximum minus the minimum. So what is the maximum value? Now, if we're talking about maximum, we are talking about the highest point that this graph actually can reach. So the highest point that the mother sine graph reaches is positive 1. So we're going to say half 1 minus, remember the formula already has a negative sign, and then the minimum, that is the lowest point that the graph reaches, which in this case, it's negative 1. You see, most when x is 270, the lowest point, the lowest y value that this graph can reach is negative 1. So we say 1 minus negative 1. Okay, and then if you check that out, that's half. 1 minus 1, that's 1 plus 1. Half 1 plus 1. And then, of course, that's like half. What's the half of 2? The half of 2 is 1. So hence we say the amplitude of the mother sine graph is equal to what? It's equal to 1, because it's half 2. The half of 2. Or it's 2 divided by 2, which is actually 1. Okay. And like I said, remember I said amplitude is the distance from the position of rest to the maximum. So the rest here is 0. The maximum is 1. The distance is positive 1. And if we do the calculation, we can clearly see that that is actually supported. The amplitude truly is, in this situation, 1. Okay. So period, 1 complete full cycle of the given graph. Okay, so in this case, the mother sine graph takes 360 degrees. Amplitude, that's the distance from the position of rest to the maximum. So we also have a formula, and we say half the maximum minus the minimum. So basically the amplitude in this case is 1. And then last but not least, the concept that I want to then look at now is the concept of range. Okay, now range is a concept even covered in your algebraic functions, your parabola, hyperbola, exponential function, and your straight line function. The range, the definition of range is simply this. Range is the possible y values. The possible y values where the function exists. All right. Range is simply the possible y values where what? Where the function will exist. Okay. I repeat. Range is the possible y values where the function exists. Okay. So when we're looking at range, we are looking at that function from the bottom up. You are looking from the bottom to the top. So you are checking where does it exist from the bottom to the top. If we look at this function, guys, look at it. I said to you that this function has a complete cycle that takes 360 degrees. This cycle that you see here is going to repeat itself every 360 degrees. So what can we clearly see then for this function from 0 to 360? The highest point that this function reaches is 1. The lowest point that this function reaches is negative 1. So we can say that the range of the function is that it has a low value. It moves from a low value of negative 1 to a high value of positive 1. And in that low value, it exists. In between, it exists as well, because you can see there is, we can see the sketch of the graph in between negative 1 and positive 1. But where are we starting? We are starting at negative 1 all the way to positive 1. So when we write down the range of the mother graph, we simply say the following. We say y is an element, and then we use square brackets. We say from negative 1 to 1, and we close the square brackets. Why do we use square brackets? It's because the negative 1 is a value that we pass or touch for this function. So from -1, you can see it exists all the way to +1. That's the highest value, and the function actually exists even there. It exists everywhere in between, but it's from the smallest to the biggest. Whenever we write range, guys, we write the small value to the big value, right? I don't know why learners write the big value sometimes first and the small value last. We always write, guys, the range with the small value first, the big value at the end. Small to big. I mean, it's just, when we develop, we don't develop from big to small. We develop from small to big. In the same vein, when you are writing the range, you are writing where the function exists, but you write it the way that it exists. You write its existence from its smallest value, which in this case is -1, from the lowest point to the highest point, from low to high, from low to high. People usually, generally, also will move from a low place to a high place, generally, even in life. So please, guys, when we write range from small to high, if that beginning point, which is the smallest point, is included, then please, we must show by the square brackets that we include that value as well. If the highest point is also included, it is there, the graph exists, we also then write square brackets to show that at 1, that value is also included. Okay? So these are things, guys, that are important for your mother sign graph. When is it not included? It obviously would not be included if the graph did not actually touch the point where y is -1. But you see, the thing is here, it does actually touch and actually exist. The function exists where y is 1. The function does exist where y is -1. Because when x is 270 for the function, when you substitute 270 in the place of x, we get a corresponding y value of -1. So the function does actually exist where x is, where y is -1. So that's why we include. We wouldn't include it if the function did not actually exist or touch that value of 1 and -1. Okay, so I hope that's clear for us. Then let's look at the cos graph. Okay, so we've looked at mama sign. You see mama sign? I hope you guys see the shape. This shape is very important. So when you are thinking of the sign graph, you must think of this. You must think of this. We go up, down, up, down, up, down. This is the basic shape. It's the basic shape. And it's so important to know the basic shape, because all graphs that you will ever draw will come from who? From mother. That's why mothers are important, guys. All things come from the mother. Children come from the mother. They are in the womb, patterned after the mother. So the mother graphs are important. You need to know this mother graph. You must know its period, the mother graph's period. You must know the amplitude of the mother graph. You must know the range of the mother graph. When you know these things, then I'm telling you, functions, you have basically laid the foundation for understanding everything else that will come thereafter. But please understand and know the shape of the mother graph. Okay, because all the interpretation, it becomes easier as you go along. So guys, I'm gonna get there. I'm gonna get to the interpretation. It's just that I'm trying to establish the basics so that when I go to the interpretation, all of those things, you can actually see its relevance. Let's look at the cos graph. Cos graph, I hope we also know the basic mother graph of the cos graph. We have 0, we got 90, we got 180, we got 270, we got 360. Right? Cos graph as well. So let's just write 1 and -1 there. This is mother cos. Let's check mother cos, how mother cos is. So if we do the same thing, we substitute cos 0 is 1. Okay, so when x is 0, when you substitute 0, we get a corresponding y value of 1. So there it is. Cos 90 is 0. Cos 180 is -1. You can check with your calculator. Cos 270 is 0. Cos 360, +1. So when you sketch, look at that shape. Look at that shape. Look at that shape. It is shaping up. It is shaping up very well. So this is the mother cos graph. This is how mother looks like for cos. All right. Look at mother for sine. Very different. Okay. Look at mother for cos. Very different. Okay. So we are going to ask the same questions. What is the period of mother? All right. So guys, take note. A full cycle of the cos graph mother is also going to take how many degrees, guys? It's going to take 360 degrees, because this mother cos graph as well, this cycle that you see here, this is a full complete cycle. It will repeat itself every 360 degrees. Every 360 degrees, the cycle will repeat itself. Repeat itself, repeat itself, repeat itself, repeat itself. So grade 10s, you need to understand that period of 360 for the mother graph. Grade 11s, you need to also know. Grade 12s, you need to know the basic mother graph. Okay. We explained what what period is. What about the amplitude? Amplitude is the distance from the position of rest to the maximum. Or in other words, we can say half the what? We can say maximum minus minimum divided by 2. So we do the same thing here. What is the maximum? Once again, we have positive 1. What is the minimum? Again, we have negative 1 for the mother graph. So that means when we say max minus minimum divided by 2, what are we going to get? I'm just going to simply write the answer, guys, because it is the same thing. Okay. We say maximum minus minimum, we have 1 minus minus 1 again. We'll get positive 2. Half of 2 will give us 1. So the amplitude is also 1 for the what? For the mother cross graph. Then what about the range? Well, what do you know? What do you know? The smallest y value where the function exists is also negative 1. The highest y value that the function exists is also positive 1. So therefore, when we write range, we say y is an element, square brackets, negative 1 to who? To 1. Okay. Lowest, highest. Okay. Then last but not least, guys, last but not least, let's look at tan. Tan graph is very, very interesting, the most interesting graph in the land. Okay. It, unlike any other graph, we'll write 0, we'll have 45, we'll have 180, we'll have 225, we'll have 270, we'll have 315, we'll have 360 degrees. Okay. Now, very, very interesting, this graph. We'll put here 1 and we'll put here negative 1. And then we will check using our calculator. Also, obviously, calculator is not going to be sufficient. We're going to check using our calculator. We're also going to check a variety of other things. So let us substitute. What is tan 0? So tan 0 is 0, not a problem. What is tan 45? Tan 45 is 1, not a problem. What is tan 180? Tan 180. Who's this now? Iyala. Tan 180. Okay, I missed something here. I missed 90 here. Problem.
Why is
135. So there's a variety of things that I missed here. Hello, Ila. Is it Ila or Ayla?
It's Leila.
Leela. Oh,
Yes.
Leila. My goodness. What a name. I'm well, and you?
I'm good. It's just a nickname it's my sister's account.
Hey, my man, I was about to say, hey, I was like, what a romantic name you've got going there.
It's nothing much. Are we doing grade 12 maths or 11?
No. There's a particular grade 10 learner who asked me to actually just rehash grade 10 trig graphs. So I'm just trying to establish basics here so that when I go deeper, there's depth and simplicity already established at least.
Okay, let me grab my pen and paper.
So, Layla, what is Layla's claim to fame, and what's What is keeping you up so late at night, my brother?
I was actually writing my maths homework.
Your maths homework. What grade are you in, buddy?
I'm in grade 11.
Oh, nice. Grade 11. Hey, it must be fun there.
Fun? Are you
Yeah.
seriously saying that?
No. Like, as in, like, dead serious. Like, no joke. You must be having
you
a
can't
ton
be
of fun
serious.
in grade 11.
There's nothing fun there.
Really?
Nah,
Now, even with the maths, buddy?
there's nothing fun.
Yo. I feel like grade 11 is the most fun grade when it comes to the maths, like ever. You know, you might. How was grade 10 for you?
Grade 10 was easy.
Yo, wow. Then you must have things in reverse, my brother. Because honestly speaking, you know, just a trend that I've observed, generally speaking, and maybe this may be very general and not specific to every situation. Of course, we do have exceptions to the rule, but like usually kids, they grade 10 because they're starting to do pure maths for the first time. Some kids, it takes a while for them to get into the groove of things, you know. But 11, my brother, once they make the transition to 11 and they start off term 1 with grade 11, they're like, man, we've seen this before. Many of the things they've seen before. And you know, and also just the grade itself, yeah, it opens up, you know, and maturity also strikes for many learners. So the turnaround happens there, you know.
Grade 11 is a bit hard than grade 10. Grade 10 was very easy for me. I used to get level 6, get level 7 in maths.
Yeah.
And now I'm in level 4. I'm like, what? How did we get there?
How did you get there?
From 7 to 4.
To 4?
Nah, that's not possible.
Yeah. No, man, that's a bit devastating though, eh?
You see, so
Term one, you got level 4.
Term 1, I got level 5. It was okay sharp.
All right, so you at least the stability there.
For term 2, I got level 4.
Okay, and what was the issue there with term 2 specifically? When you reflect back,
I think it's paper 2. Oh my god.
Specifically what in paper 2?
Euclidean.
Okay, Euclidean. But besides Euclidean, because I mean there's other things in paper 2.
I mean the whole of paper 2 is just not for me.
Yay. But then in grade 10, paper 2 was fine.
Yeah, it was easy, it was flowing.
Yo. This is very interesting for me. You see, the thing is, the trend that I've observed, and this is even with learners that I've worked with, is that like I said, learners in grade 10, they like, hey, say, but then in 11, it starts opening up, you know. One of my other learners that I've been working with here on this platform since you see, the thing is, we actually opened the year a bit earlier than everybody else. We started doing grade 11 work, and it's just, I guess, fortunate for those kids that when I started having this platform where I was doing live lessons, those kids, they would join my live lessons. This was in December last year. And we would do grade 11 term 1 work. So we started things off early, very early, you know.
You see, I think they got the knowledge earlier, so it would be easy for them.
I'm
not
telling
just
you,
for us.
But that's the way to go, man. If you want to do well in maths, you have to do that, you know.
Yeah, I've been seeking some tutors, yeah, whatever.
Yeah.
And it's hard for me to understand them because, like, I think I need special whatever.
You are killing me, bro. So you need special whatever.
Yes, it's special whatever. I don't know what it is.
I hear you, bro. I hear you. At least you are the one who's seeking for assistance, and it seems like you are searching high and low.
Very bad. Very bad.
No, I hear you. I hear you, my man. I hear you. I hear you very well.
See now, I'm still organizing my things for writing.
Okay. Okay, so just allow me to continue then. I've heard you, and thank you for sharing your current
Problems.
situation and plight. We will see, you know, as we move along, maybe how we can also maybe add our 2 cents and assist where we can. But yeah, it's like I said, you know, I do not promise heaven, but like I said,
that would be appreciable.
not a problem. All right. No, sure, like, yeah. So, guys, back to the Tina. Please send me a DM if you want to talk to me about specifically what you are saying in the comment section. So, when we look at this, the trig function for tan, it's a slightly different from the mother trig functions that we were dealing with, because with the sine graph, pretty shapy, you know, like I said, the shape is like that. And then with the cos graph, we also saw, you know, there's like continuation, there's continuity with the graph, you know, there's no interjections, there's nothing that basically stops the graph. It just continues. It's a continuous function. Even with the sine graph, it's very nice and continuous. Now, we experienced a bit of a situation here when we are dealing with the tan graph, because the tan graph, on the other hand, what we observe here is that we look at the angles, all right, on the x-axis, 0, all right. All of a sudden, we also want to observe 45 degrees, because interestingly enough, with the tan ratio, we need to actually check tan 45. Tan 45 will actually give us a positive 1, all right. But then you go and press in your calculator tan 90. You will experience something that is really, really baffling to the mind, because the calculator all of a sudden shows maths error, you know. That maths error speaks to the fact that at tan 90, the function is not defined, okay? It's undefined. So as the function is not defined, it means that the function does not actually what? Exist. So here we talk about this thing that we have also mentioned and spoken about when we were looking at our functions that are algebraic, you know, your hyperbola and your exponential function. They had what we refer to as asymptotes, okay? Now, an asymptote is simply a boundary line, okay? It's a boundary line. And what about this asymptote? It's a boundary line where the function does not what? Exist, okay? So the function does not exist on that asymptote. We have what we refer to here as a vertical asymptote. Now, the vertical asymptote in a tan function, okay? So in this particular situation, we can see tan 90, that's the asymptote. So x is equal to 90 degrees there gives us our vertical asymptote. Because remember, x is 90 everywhere along this vertical line, okay? Then we move on. What's tan 135? We can see we have -1, okay? We get -1. Tan 180 is 0. Tan 225, we have +1. Once again, when we say tan 270, bam, we are struck with that asymptote once again, because our calculator says maths error. Are you with me? So the function is not defined, does not exist on this vertical asymptote. So our asymptote is exactly that, okay? It's exactly that. Then moving right along, tan 315, hey, tan 315, we can see we have -1. And then tan 360, we have 0. So that means here, if we to sketch here, right? And I just want to speak a little bit as well on this graph as it increases, approaching this line but never touching it, all right? So if you were to go to your calculator and punch in tan 89, you will be very, very shocked at the value that you get, because the way that this function increases, it's at an alarming rate. As this function approaches 90 degrees, it begins to increase at a very, very interesting rate. And in actual fact, not just that, but the closer and closer we get to 90, the higher and higher the function seems to get. All right. And as well, you will find that the more and more we get to 90, it's almost as if that function approaches, or let me say, approaches what we refer to as infinite. Are you with me? So, for instance, you'll type in tan 89, you'll get a pretty high value if you ask me. But if you were to say tan 89, let's say 0.9, just add a comma 9 after that 9, you'll see how high that y value actually is. Then you say tan 89, and let's say after the comma 9, you add, let's say 5 nines, 89,99999. The value immediately changes from, yes, an extremely high value, but it's way higher than the previous amount that we had gotten for y. So what I'm saying is that the more you approach, as you approach 90 degrees, this function approaches infinity as well. Okay, so but then at 90, all of a sudden, tan 90, the function, does not exist. Okay, then immediately after 90, if you were to say tan 90.9, once again you get an extremely low value. It's a negative value, but it's extremely low. All right, but the more closer you are to 90 degrees from this side, so let's say, for instance, we say tan 90 point, and then we say 11111, okay, which is much lesser than tan 90.9. You say tan 90.1111111, you're going to see that that value is actually much lower than the value of tan 90.9. And it is extremely low, extremely low. So it means that the more closer we get to 90 degrees from the right side, then the lower and lower the y value. In actual fact, that y value approaches negative infinity, that much more. But do you know what? This function will never touch this boundary line, which is the vertical asymptote. Because it is our asymptote, it does not touch that line. So this is what's happening even here, all right? We approach 270 from the left, the function approaches infinity, okay, for our y values. We approach the function from the right, this side, okay, then 270 from the right, the function approaches negative infinity, and so it goes. So this is basically what we see with the tan function, the tan mother graph. This is its shape, guys, and we need to understand that. So then if we answer the 3 questions that we had answered for each respective sine graph, the mother graph, cos graph, the mother graph, now we can answer the same questions for the tan graph. We want to ask the question of what is the period of this tan graph? Remember, what did we say period is? We said period is basically the number of degrees it takes to complete one full cycle of the graph. We saw with the sine graph that it takes 360 degrees to complete a full cycle. This is one full cycle. In science, you guys refer to it as one complete wave. When we're in grade 10, you did waves, you said it would be a one complete wave. All right. So in functions, we say one complete cycle would take 360 degrees. And the graph repeats itself every 360 degrees. This is the shape of the mother sine graph. Then for the cos graph, same thing. We said it takes 360 degrees to complete one full cycle. So the period is 360 degrees. Now with the tan graph, look at this, guys. Do you see this? All right. Do you see that this here, better yet, represents a full cycle of the tan graph, this here, okay, this here, one full cycle. Now, if you measure how many degrees it is, all right, from 90 to 270, you actually see that the number of degrees it is from 90 to 270, where we actually have a representation of the full cycle of the graph. What's 270 minus 90? I'm sure you guys can see it is 180 degrees. Thank you, Lila. It is. I'm going to call you Lila since you are using the account, my man. You're just going to have to bear that one.
No, it's okay.
Yeah, so it's 180 degrees, Lila. You are 100% spot on. So that's why we say the period of the tan graph is 180 degrees. It is not 360 like the other two mother graphs, sine and cos, but it's 180. So when we know that, this will further assist us in other things that have to do with trig equations, where we have to find the general solution, because when we know the period, then it also relates back to those particular aspects that we cover when we are doing those things. And obviously, when we know the period as well, it will assist us with other questions that relate to that for grade 11s, grade 12s, and so forth. But for grade 10s, guys, please, let's understand the period of the mother tan graph, because this is the mother, guys, the mother tan graph. So the mother tan graph has a period of 180 degrees. Let's answer the next question, amplitude. Remember, we said the amplitude, okay, the amplitude of the, tan graph. In the comment section there, I see MJ, what time do you start your live? MJ, hey, you know, almost I told you guys that it's very hard for me to actually pinpoint when I start my live, because it depends on the situation. So for instance, today I was able to actually get started at 9 o'clock because of circumstances in my home environment. So yeah, I'm here now at 9. Sometimes I start at 8, sometimes I start at 9. So it's just a bargain between 8 and 9. It just depends on the situation. So the best bet is to actually make sure that you are following me, and also that the right indication notifications can actually come through to you when I am live, so that you can catch me when I'm there. Okay, so amplitude here for the tan graph, guys, we say here that the tan graph has no amplitude. And maybe you're going to ask why. Remember that the tan graph, unfortunately, does not have a maximum and a minimum. There's no specific place where we say, this is the highest point, it stops there. Or no, this is the lowest point, it stops there. With the tan graph, we can see that it can go on in the positive direction infinitely, all right? And the infinity, remember guys, is not a number. Infinity is just a concept in maths that shows us that numbers go on forever in a positive direction. Also, negative infinity is just a concept in maths that shows us that numbers go on forever in the negative direction. It's not numbers, those ones. They are just a concept to help us understand the never-ending nature of numbers. So, seeing as that's the case, can we then write the amplitude, knowing that the amplitude is the distance from the position of rest to the maximum? Well, you can clearly see that here we can't talk about the maximum. So therefore we can say there is no amplitude. Ayikho. Ayikhoni. Right, let's go. The next thing, the last thing, is the range. The range of the the tan function, the mother tan function. What would be the range? Let's hear some people. Laila, do you know what the range of the mother tan graph is? Seeing as though you were good in grade 10, I'm sure you can just tell us what the range is.
Isn't it like isn't it 90 to 270?
Okay, now let's go back to the definition. What is the range? Range is the possible y values where the function exists.
Isn't it negative infinity to positive infinity?
Now you are talking, my leader. But now I want you to indicate and be specific. You said negative infinity. So how would I write it here?
So you're gonna start by writing y element.
Thank you.
Then it.
Sorry, I think you just broke there a little bit. You said y element?
And then the square bracket.
Square.
Is it square? Yes.
Just gonna allow you to write, to tell.
Negative infinity is to positive infinity.
Okay, and then?
I think you put the curved bracket.
The curved ones.
Yes.
So I say square curved.
I'm not sure.
Okay, no, that's fine. That's fine. We are going to be sure, don't worry. So remember, this is infinity, and as we had indicated earlier on, infinity is not a number. It is a concept that just shows us the never-ending nature of numbers. So remember that square brackets or closed brackets mean that thing is included. If we say open, it means that thing is not included. So can we include something that never ends?
No.
Yeah, so therefore our brackets, can they be square or closed?
No.
Yeah, so then let's just fix that. So our true answer that we would wanted to write is actually open. It can never be this, okay? All right. Yeah, so I hope we're clear there, my lead.
Yeah,
my brother.
Clear.
Yeah, amen, hallelujah, hallelujah. Hallelujah, everyone. Yes. Okay. So that about clarifies the basic concept of functions when it relates to Landok. Now, in grade 10, these here are what we call the parameters that affect or influence the change of a function. These here are the parameters that affect and influence the change of the course graph. These here are the parameters that affect and influence a change in the tan graph. A is very critical because it does something to our graph which we need to take note of. Q is also another parameter which is very important because it does something to our trig mother graph. So this is where all the children come. The mother, y is equal to sine x, will give birth to the children. You see? And they are not the same, the children from the mother, but there are important things that we need to note about the mother so that the children, we understand them from the mother. Hey. So it's very important to understand the mother. If we know the mother, the children, it will be easy to unpack them. No problem. So, for instance, let's say I said I have y is equal to sine x, which I want to compare to y is equal to 2 sine x. So if I want to compare these two functions together, let's say I asked you, what transformation happened to mom? What transformation happened to mom to get to daughter? What is your thoughts, my late? What would you say in words if I was to ask about the transformation that happened to mama to get to the daughter?
Yeah, because of the amplitude there, which is our A, the graph will move and you show 2 points up and 2 points down. I'm not sure if iyazwakala anything you sure.
All right. I think I'm having an idea of what you are saying. I just want to reveal this comment that this person also is saying there, Ulunga Lubelo is saying, Mom was stretched to form daughter.
But like the amplitude cannot stretch. It goes, I think, is it vertically? Yeah, vertically. The amplitude.
All right. No, you know what? This is what's nice that we are here because we can learn stuff. All right. So Lunga Lubelo, I hear what you are saying there. Lunga Lubelo is saying, Mom was stretched to form daughter. All right. Can you maybe Lunga Lubelo can also be a bit more specific about this stretching, right? Lila, I hear what you are saying. You are saying there was a vertical, what? Are you saying that there was a vertical movement up and down?
Vertical shift.
Vertical shift. Okay.
I don't know if it's,
so there are
it's
two
the
things.
correct term.
Sorry?
I'm not sure if it's the correct term, but like, yes,
Okay.
it's a vertical shift.
Okay. Let's look at these two terms because now I'm seeing you saying vertical shift. Lunga Lubelo is even explaining further and saying there's a vertical stretch.
Which maths is this? It's pure maths.
You must don't mind the people in the comment section because they are very interesting. That's why sometimes people don't understand. I end up blocking people for no reason and they don't understand why. And then they come begging me there in the message with someone else's account. Please accept me back. Please don't do. You guys must be vigilant about what you say in the comment section. Which maths is this? It's high school maths, grade 10 specific, but also relevant for grade 11 and 12 because it's the basics. It's the foundation to that. Okay, so if we are looking at 1, the coefficient of the mother,
yes,
2, the coefficient of the daughter or the child, we are saying, or what we want to understand is what transformation occurred with the mother so that we could attain the daughter. So we are looking at two concepts here, vertical shift and vertical stretch. And what we want to then understand is what does shifting mean? If you are talking about a shift.
Can I fix myself?
Okay, please go ahead if you're going to fix yourself.
I didn't want to say vertical shift. I wanted to say the graph of the daughter, it moves 1 unit up. Is it 1 or 2? Yeah, it's 1 unit up, not a vertical shift. I think a vertical shift is another term of something.
All right. Okay. Now we are going to also now consolidate what you have said. So you said 1 unit up.
Yes.
Okay. Now, all right. Now let's come first and check what does shift and what does stretch mean. So when we're saying shift vertically as well, it means there are two things that could happen. We can either shift in an upward direction or we can shift in a downward direction. Okay? Yeah.
Yes.
This is called vertical shift. And the parameter that a vertical shift is basically associated with is the parameter Q. Sihamba sonke.
Sihamba sonke.
There, ne?
Okay.
Stretch has to do with the parameter A. It is associated with the parameter A. Okay?
Okay.
Yeah. And there is basically two ways that we can see such happen. It can either be a vertical stretch or a compression. Okay? So we could stretch it vertically or we could compress it vertically. That's another thing that we need to take note. Okay? And yes, Lunga Lubelo, it does go hand in hand with functions. Very key, this thing. All right? Very, very key. So let's go and observe then Okay, because I just want to talk about the concept. We'll go back to this, all right? It's very important to understand the concept first. So vertical shift has to do with Q. So we say if Q is greater than 0, key up. Q is less than 0, it down. All right? Very important. Let's check at A, the stretch. We usually say if A is greater than 0, then give vertical stretch by a particular scale factor, by a factor of whatever, you know? If A is between 0 and 1, between 0 and 1, in other words, it's a common fraction, then we talk about a vertical compression. It's compressed, my friend, by a factor. All right? And then lastly, if A is less than 0, in other words, A is negative, we are talking about a reflection in the x-axis. These are very important parameters that we need to understand first. What is their nature? What do they do? A greater than 0, give vertical stretch by a certain factor. A is between 0 and 1, give vertical compression by a factor. A less than 0, give reflection in the x-axis. In other words, sometimes we can even say reflection in the line or along the line y is equal to 0, because remember, the x-axis is the line y is equal to 0. And oftentimes this one, in as much as kids know that it's reflection in the x-axis, they tend to not know it when they are saying reflection in the line y is equal to 0. The line y is equal to the x-axis. Okay. Hi, Bob.
Yeah.
Hi, Lila. I hope we are good. Let's come back here. Can we now, understanding the parameters of A and Q, can we now describe the transformation from the mother to the daughter?
I think so. You said in words, right?
Yeah, in words.
And you see, now I'm lost.
Look at Lunga Lubelo there in the comment section.
Vertically stretched by a factor of 2.
Does that make sense?
Yes, it does make sense, which I didn't think he should have got to actually big.
No problem, my leader, no problem. Oftentimes we know exactly what we mean, like, because I'm sure when you were saying it, even in the beginning, you knew exactly what you meant. I'm sure if we were to actually represent what you felt you meant in what you were saying, and we were to see a visual picture of what you were meaning, I'm sure you were talking about a vertical stretch, clean by that fact, right? Yeah. But the thing is, we oftentimes do not have the words that are appropriate that will represent what we mean, especially in the test, and we don't write it the way that we mean it. And that's where sometimes we actually lose stuff.
Oh, so can I ask? So
yes, please do.
If our A is greater than 0,
yeah,
so we use the vertical stretch by a factor of.
Amen.
Then if it's less than 0, we use the reflection in the x-axis.
Amen.
Okay, I get it.
Okay, that's very key, very key. Check me out, change the question a bit there. Let's say we had y is equal to sine x, and then we had y is equal to negative 2 sine x. Now, See, to me, this will be very interesting what you will say in words.
Okay.
Mama, this one is a daughter, and I can tell you about this daughter. This daughter decided to dye her hair.
Okay, I think so. Since this side we have a negative, the negative, I think it only shows us the what's this? Can't be direction. No. It shows us your maths.
Okay.
Isn't it the reflection, the number, the third point?
Okay, definitely. There's reflection that we can see. Why do you say
Because it's
reflection?
less than 0.
Okay, good, definitely. Okay. But more than that as well, what else? Because that's not the only thing. Because remember, this was 1. Now all of a sudden it's what? -2.
Well,
So there's two aspects here.
There's
the negative
vertical
sign.
shift.
There's the 2.
There's a vertical shift.
Okay, now be careful. Are you saying there's a vertical shift? There's
no,
like you.
no, the vertical stretch. Oh, sorry.
No problem. Okay. Yeah. You see, that's why I was saying initially, we know what we want to say. We know it, but the thing is, when it comes out,
It's a problem.
I'm telling you, Bob. I'm telling you. And most kids are simply doing exactly that in papers, in stuff. It's especially true when we haven't had the opportunity to deal with the content for a very long. Let's say it's been a while that you've done functions, and all of a sudden maybe a teacher comes and says surprise test, and you like, yeah, okay. And then there's certain things that are kind of fuzzy in your head. They're not as clear. So it's important to first establish the conceptual, understanding. Mr. TK, thank you so much for the gifts there in the. Thank you, Baba. I really appreciate it. Always a joy. There, Mr. Laila, there's another friend of mine there, Mr. TK. He's running a tutoring service. He's got a sweet, what you might call TikTok platform as well, where he teaches kids like into the dead of night. I could never do what he does, man. He does it so well. At 12 o'clock, that guy, right, is doing the things, live lessons for.
12 o'clock.
Yeah. And the guy, more than just help with maths as well, he helps with science, So he's a one-up on me because, he's got the science knowledge for days, bruh, Yeah, so he's definitely someone else to follow, even for the people that are here, man. He's the guy, he's the man.
He just gained a follower. I'm gonna join his lives. I need this.
No, follow the man. So Laila, what we were saying there is we need to get our terminology straight and right, and then we need to be consistent in actually using it,
Okay.
Yeah. Otherwise, my leader, I think we are getting somewhere, aren't we? Because I'm sure even you're like, okay, now I see. So once you see it and you know it and you understand it, then you need to just be consistent. You see?
Yes.
Yeah. So here, please, initially mother was positive. Now daughter. That's why I was saying daughter has, also, a different shade of color in that hair as well. Yeah, well. So the negative sign speaks to reflection in the x-axis. You see? But
that tells
itself,
us that it's less than 0.
Yeah, the 2 itself speaks to that vertical stretch by a factor of 2. So you have to speak to these independently, because the thing is, even initially, this is positive, you see? The coefficient of sine x, it's positive 1. So what happened for it to have -2? You can speak to these independently. You could say, first, the function, it vertically stretched by a factor of 2. Ne? That's excluding the negative sign. Then it what? It reflected in the x-axis.
That's valid.
Yeah, that's valid and it's full, bruh. Like, I mean, who can argue with you after saying that?
No one. Uzargue what's in.
I'm telling you. Then you silence the examiner and you silence everyone. You see? Yeah, even the moderator will come and be like, hey, I know you're this. Yeah, it's boy. I know this. Yeah, you see? Yeah.
Okay.
So I hope we are good now with that. It's very important. And the order here, because -2 is multiplied to sine x, this relationship that exists between minus and 2, and the fact that they are both multiplied to sine x, allows you to actually, you could first, if you wanted to say, it reflected in the x-axis, then stretched by a scale factor of 2. Or you could say, it vertically stretched by a factor of 2, then it reflected in the x-axis. Both orders will be fine. Whether you start with this, you end with that, or you start with this, you end with that. Both would be
as long as they are there.
Yeah. Because, why? Because of the relationship of multiplication that exists between the negative, the 2, and the sine x.
Oh, okay.
Yeah. Now I want to move here and go to something else. Okay. You see, so here we were dealing with A, all right?
Yes.
Now check this one. Let's say we had y is equal to sine x, and then we had y is equal to sine x minus 2. Let's start there, and then I'm going to move on to another one. What about this one, my lead?
So this one, I see that there's a vertical shift.
Yes. Yeah, what you've been longing for.
No, I see.
Okay. So this one you can see it's a vertical shift. Clean.
It's a vertical shift.
Yeah, because the coefficient of sine x from the mother is 1. It's still 1.
Yes. Yes.
Right. So as you said there's a
vertical shift.
Yeah, because here obviously we would assume plus 0, minus 0. But here you can see -2. So
yes.
This speaks to a vertical shift. Okay. But you would say downward by 2 units. You see?
So when I actually write, because it's negative, I say it's vertical shifted or shift downward.
Yeah, you can say vertical shift down by 2 units, or yeah.
Down by
2 units. Yeah.
Okay.
Yeah. Yeah, and that would be that. Because A is unaffected, but Q is affected. And we know that Q has to do with vertical shift.
The vertical shift.
And obviously, since it's less than 0, minus, that means down. Yeah. Yes. Yeah. You see? Okay.
Maths isn't hard after all. I see.
Maths isn't hard after all. Yeah, maths isn't hard if maths isn't hard if things are clear. If the conceptual understanding is clear, you are clear yourself about the concept, then it's not hard. But it's very difficult when there's confusion about the concept. It's a pain. It's a pain. All right, and then I just want to do one last one. Exactly, Lunga. You basics makes maths easy. So there's a learner that last year, in one of the neighboring schools, I had a chance to teach this particular learner in grade 11, but then in a particular program, and this learner last year in grade 12, he got 100% for maths.
100.
Yeah. So when he got that 100%, I actually asked him to send me a voice note, because he's now studying actuarial science in Wits University. So I said to him, can you send me a VN and explain to me how did you get 100%?
Yo.
Do you know what he said in his VN? He was like, sir, if there's one thing I did, especially when it came towards the time to write my trial exams and my final, all I did, I just went back to the basics for everything. Basics, everything. Basics, just basics. And I made sure that I understand the basics. So I was like, yeah, that's power, Baba. That's power. And I mean, really, like, so it's like what Lunga Lubelo was saying there. Basics makes math easy. It does. Because once you understand the basics, like for everything, then it's like, it doesn't matter. They can try and make a question complicated and they can make it complex, It can be a new question that's never been asked before in an exam. But you will have a way of coming out of that if you understand the basics, because you can be able to read the question and interpret it according to the basic knowledge that you have of that particular topic. If you know the fundamentals, and if you also are practicing, there's no way you will not be able to come out of that one. So and of course, that young man, he worked, man. He sacrificed. He gave his time. Provincially, even he was actually a top learner in the district, in his particular district. He was actually the top learner, and it was fun in the sun for him for days. So, anyways,
is wild. It's very wild.
Yeah, and Kaloko Elian, that's what I was saying to you. Me with grade 11, you see that group of learners, the ones that I was talking about. I have a learner in June that got 100 as well, writing common papers. The boy is actually from Limpopo, and he got 100. He got 100 because term 1 he got 99. And I remember when I met him over the live lessons, like in December, because literally December time, festive, whilst everybody was having fun, we actually got close, and I got to know him via WhatsApp. And then he sent me a message, and he was like, sir, I was like, what's your goal for this year? He's like, sir, I want to get 100 this year, just 100% for maths. I was like, okay, no, that's fine. I'm sure you'll get it. So term 2.
He made sure.
Yeah, he made sure. Term 2, he sent me his report card. He's like, sir, I got 100. I saw his report card. And when I looked at his report, I was like, you are going to be. The Limpopo people must be very scared of you. I can see you in grade 12 doing crazy stuff. I looked at the rest of his subjects as well. He has an average of 94% overall, that boy. Yeah, so I was like, this one is going to kill it, no doubt. For days, flames are coming for that one. That one will just do the thing. So that's inspiring. That's why I'm saying some kids, man, that's why I'm saying that if you put in the time, and the grade 11 is really, like, literally, guys, grade 11 is a breeze. I know it comes with a lot of work and all of that stuff, but grade 11 is a breeze. And some people, they unlock it and they do it. Grade 12, even 12. 12 is just got hype around it. That's all. Grade 12 has hype because there's this thing of writing final papers. And the only thing that's there is hype. If you would take away the hype, people would see how easy grade 12 is as well. Because if your grade 11 is solid, 12 is nothing. You see? Yeah, it's nothing, guys. It's nothing, guys. So that's why, for instance, some kids, they show you that it's nothing and they get 100%, and then you guys worship the ground that they walk on, and they just like, hey, we just put in the time. We made sure we took care of basics, and their answers are just so simple, and you think to yourself, Haibo. But they are speaking their truth because they put in the time. All right. Anyway, sorry, man. I'm getting a bit distracted there with this performance and stuff. But yeah, I'm just wanting to also say to you, my leader, that yeah, if you really want what you want, you'll get what you want. I know, for instance, you grade 11s, it's important for you that your end of year report card is solid. So if you want to make it solid, make it solid. It must be solid because it's what you are going to apply with come next year, you see?
Yes.
Yeah, so you need to have a solid report card, one that does not have questions as to whether we should accept this boy in the course, give him provisional acceptance or not. So yeah, you guys do the things. Let me just, I want to do one last one. Y is equal to cos 2x, and let's say we had y is equal to this should be fun. 4 cos x minus 2.
Okay, I see what you're doing there. So no,
You see what I'm
seriously.
doing there?
Yeah, I can see. So as we can see on our mother graph, okay, that's not the actual mother graph, but okay, it's 2 cos x. While on the children, we have a 4 now. It's not a 2, which means it's affected, which means it's our vertical stretch, and it's Konje, how do you write it? It's a by a factor, yeah, it's a vertical stretch by a factor of 4, right?
Okay, you're saying by a factor of 4.
And then on the Q side, we see that we have a negative 2, which represents our vertical shift down by 2 units.
Okay, all right. I see what you said there, but I want you to note something here. You see, this was 2.
Yes.
Yeah, but this 2 increased and became 4.
Oh, okay. I get where you go.
So if it was the mother and we had y is equal to cos x, I would understand what you said. You said it vertically stretched by a factor. What did you say? By a factor of 4.
4.
Because it's 1 times 4, so it's a
4,
factor of 4.
No,
But would
I
you say
get
the
where you're
same thing
going.
about this one? To get 4 from 2, what did we do?
So we multiply by 2. So which
Exactly.
means I
So
should
what's
have
the
said
factor?
it's 2.
Exactly. Are you with me? Are you feeling it then?
Yes, I'm feeling you.
Yeah. So that's basically what you need to take into consideration, right? Maybe these questions are not questions you'll be asked, but like I said, it's so important to know how to describe the transformation of a function looking at the parameters. Okay. I mean, we learn about A and Q for that very reason in grade 10. All right. And we talk about A and Q and what do they do for that very reason, so that you guys can describe transformation. You can tell me what happened. All right. Yeah. So rightfully, as you have said, since we are moving from 2 to 4, we have to, when we are talking about the vertical stretch, we are going to say by a factor. It increased by a factor of what?
Of 2.
Of 2, exactly. All right. And here's another thing, Lid. It's so important that the order in which we describe transformation is indicative of this, the order of BEDMAS or BODMAS, if you want to say it that way. Okay. The multiplication, meaning the A, needs to come before the Q.
Oh.
Yeah, because the relationship of A with the trig ratio is one of multiplication, but the relationship of Q with the trig ratio is one of addition or subtraction. So when we describe transformation, it has to be this followed by addition and subtraction.
Oh, okay.
Yeah.
I think we're getting somewhere. You see, now you are making things easy for me now. No, it's like you're a guardian, because like if like my real teacher like would have said this, gosh, it would have been a problem because like, nah, I told you I need special treatment.
Okay. No, that's no problem, right? So we can see that then. Yeah, well, increase by a scale factor of 2 or increase by a factor of 2, the vertical stretch, okay, by a factor of 2. And then after that, we can see that from there, you know,
Yes.
yeah.
And then on the -2, we said it
Vertical shift
vertically
down
shift
1
down by 2
by
units.
2 units. Yeah.
Okay.
Yeah. Okay. But I think that has exhausted literally the stretch, the all of that stuff. It's yeah, I think we should be at least fine and better there.
Yeah, it's more simpler.
Yeah.
With your explanations.
Yeah. All right. Yeah. Now, me, unfortunately, now this is where I kind of have to kill it. Actually, like I have to can it here. This is my time limitation because yeah, me, I unlike my friend that I was speaking about earlier on, he yeah. Last one, lunga lubelo between one, or you wanna check one where okay. So okay, let's check this out. Okay, Lunga Lubelo is like saying there in the comment section, thank you so much, Natalia. Natalia is like rolling out the roses there. Like, yeah, thank you so much. Thank you. I appreciate
And
it.
I also have a question about something out of this content, but it's math. It's math. It's about the sine rule.
The sine rule. Oh, which you guys are busy with at the moment.
Yeah.
Is that what you guys are busy with at school?
Yeah.
Okay. Eva Sikuluma, you are very welcome, sir. Very welcome. Sorry. Okay, I'm gonna attend to that just now. I just want to check this out because Landoka, who's this guy? Someone in the comment section there, Lunga Lubelo was saying the last one. What about this one? The vertical compression by a factor. We did not showcase a question like that. So let's say we had y is equal to. Okay, I think let's move to tan. Y is equal to tan x as opposed to y is equal to half tan x. Oh, actually, sorry guys, let's okay, I think I want to avoid tan with this one because there's something that I'm now it's registering with me. Y is equal to cos x, y is equal to half cos x. Okay, all right, so here we are. Okay, because remember with yeah, so y is equal to cos x and y is equal to half cos x. So in this case, the mother graph is cos x, but then yeah, you can see most the daughter y is equal to half. You know, so then when we describe the transformation here, what would we say?
So we have a vertical. No, it can't be a vertical shift because if it's half, Mara graph, we have 1.
Yes.
Which means the vertical compression by a factor of 1/2, which is our half.
Exactly. That's what we would say, hey? So here we would talk about a vertical compression by a factor of half. By a factor of half. Simple, straightforward. That's basically how we would go about with our description of a being between 0 and 1. Okay. Yeah. Because I think that's something that my good friend Ulunga there was like saying, sir, what about that one? Okay. So I hope that one is sorted out. I hope at least we have an idea then. When the value of a is between 0 and 1, that's how we would go about it. Lunga, thank you so much. You were also very helpful there in the comment section. So thanks a ton, buddy. Like, I mean, I feel like you really pulled stops there. So what did you say you have a question about when it comes to the sine rule? Maybe I can conclude on that note. Thank you so much to those who are joining in, wanting help specifically with trig graphs. All right, maybe we'll have another segment of trig graphs. Let's say, yeah, tomorrow won't fly. Tomorrow is what? Thursday tomorrow. Yeah, maybe Thursday evening. Maybe we'll do it. We'll do a segment on that, but we'll definitely see if we can't pick up on more functions, trig function related content, so that yeah, we can also explore exam type questions. We just looked at the concept today, but maybe we can look at other exam type stuff. Natalia, thank you so much as well. Really appreciate it. I appreciate the compliment. It's, yeah, I don't know, guys, sometimes when you give these compliments, I'm humbled. Yeah, and I just say glory be to God, because that's always like one aspect. I mean, he's the one. He's the one that
Thanks, Natalia.
takes away. Okay, so do you have a specific question before you wanted to look at for the sine rule?
No, I don't have the specific question because we just started about this topic and I don't understand anything.
Oh,
So
okay.
the teacher
All right.
Explained
So
what.
let me just explain. Let me explain to you quickly with the sine rule. Sine rule is very nice. We actually did sine rule. I think a few. Natalia, you were here, right? I think 2 nights ago we did sine rule. we did sine rule, cosine rule, and area rule. We did like all the rules, and then we looked at certain questions that have to do with numerical, how to find the numerical side, and also how to find the angles. And then I think we also looked at variable type questions, because there was a particular young man in my group that asked a variable type question on we had to apply the sine rule or area rule, cosine rule. And yeah, man, that was actually a fun session. I think that's where Natalia landed. That's where I first had the encounter, if I'm not mistaken, or was it the live before? Okay, all right. So let's look at that very quickly. Sine rule, Baba. So in grade, I like taking it back a bit. In grade 10, do you still remember? Because grade 10, it seems like that was where you had happiness.
Yes.
Yeah, you were very happy there, right?
Mm-hmm.
The maths was mathing.
Yeah, it was not difficult, man.
Okay, so in grade 10, if you wanted to find a side,
we used the theorem of Pythagoras.
Or an angle, given an angle, you could simply use wa. Ne?
Yes.
Any side and angle, bruh. If you are given enough information, any side and angle that you want, you either use the definition of sine, opposite over hypotenuse, you can use the definition of cos, adjacent over hypotenuse, you can use the definition of tan, opposite over adjacent. Hey, it was nice, Baba.
Yes.
You talk about romantic maths. Romantic maths. This was romantic maths. Romantic mathematics. I don't know if you've ever experienced romantic maths. This was romantic maths. Yeah. Yeah. The first 2 months, or the first month. Yeah.
I'm not to see this one. This one is
I'm just trying to see maybe if I can't find, because maybe it will, because I'm just thinking of time and having to write down starting from the beginning. I just want to see, because I did, or maybe it will be better if I actually write down afresh. Okay, let me just leave that. Okay, so triangle ABC, grade 10, we'd find an angle, a side or an angle using SOHCAHTOA, no problem. It would make life so easy. So for instance, if I was given, let's say this was the triangle, let's say they had an ABC, and then let's say maybe this was 40 degrees, and let's say this was 8, and this was 90, and then they said calculate the value of x, and x was there, you see. Then I would say, what's that angle? It's 40 degrees. What is that angle in relation to that side? That's the opposite side. What's that angle in relation to this side? That's the...
Isn't the hypotenuse?
Exactly. And then you would say, that's O, that's H. What's a relationship that has to do with opposite and hypotenuse?
It's sine.
Hence, I'm saying SOHCAHTOA was what was used there. So you just say sine of what? 40 degrees is equal to x over 8. Yeah, and it was just nice there. Cross multiply, because the 8 is in the denominator. X will be the subject. You just say 8 times sine 40 degrees. Calculator, answer would give you, voila. 8 was nice those days, man. You see?
So it's 8 sine 40. Yeah.
Yeah, 8 times sine 40.
It's 5,14.
Yeah, you see. Yeah, and then obviously if there was nothing, you'd write units just to sort of like say, I know what I'm doing. Because I don't have an SI unit, it just means I write units. Okay, so that's finding a side. Okay, remember, if the unknown was in the denominator and the known was in the numerator, you would do an interchange between the known and the unknown, so that you can find your answer. I mean, just algebra, because it's substitution, algebra, answer. Substitution, algebra, answer. Trig ratio, substitution, algebra, answer. I mean, simply that. Okay.
Yes.
All right. I just want to explore one where there's an angle, because I've just given you one where we have to find the side. What if we need to find an angle? They had, let's say we had theta, let's say we had 24, and let's say we had 16, that was 90. Let's say this is DEF, and they want us to find the unknown angle theta. So we do the same thing, right? In a way that, what is theta? Okay, that's theta, the angle we want. What's that in relation to the angle theta?
So it's opposite.
And what is this in relation to the angle theta?
Hypotenuse.
What's the ratio that works?
It's sine.
Exactly. So we'd say sine theta is equal to 16 over 24. Then we want the angle, so we take arc sine on the right, 16 over 24. We use the calculator.
It says 16 over 24, right? Yeah, the answer is 41,81.
Exactly. Then we would know, but oh, this is an angle, so we don't forget degrees. We don't write units because it's an angle, so we'd always be conscious of what we are dealing with, so that we don't do the wrong thing. Right? So this was the glory days of grade 10. And the glory days of grade 10 are important because even as we go to grade 11, we need not forget this. In grade 11, so this here is what we would do to get rid or to deal with what we call the rats.
Okay.
Right angle triangle. Yeah. In grade 11, all of a sudden, on a Monday.
All of a Monday.
I'm telling you, all of on a Monday, but it's a Wednesday. We are given non-rats.
Which means it's just a triangle.
Yes, and it's not right angled. So then the $1 million question is, how do we deal with a non-right angle triangle? So they say, or they suggest, there are rules, 3 of them that you need to know. One is the sine rule. If you want to find a side using the sine rule, you just make sure that in your numerator, the sides are there. So you would like A over sine of angle A, B over sine of angle B. Take note that this A represents the side opposite the angle A. This B represents the side that is opposite the angle B. This is what we call the sine rule. And we use two ratios for our given triangle to solve using the sine rule. If we want to find a what? A side. We make sure that the sides are written in the numerator. There are conditions. There is a condition to using this rule. You must have a side opposite a given angle. That must be given to you. And then the side that you are looking for must be opposite an angle that is given. Or, if you want to find the angle, then you must be given a side and an angle opposite it. Then the angle you are looking for must be opposite a given side. That's the condition of use for the sine rule.
So I'm not wrong if I wrote to we use the sine rule if we are looking for a side on a non-red, right?
Yes.
And then I wrote we need a pair, a angle, and a side opposite to the angle given.
Yes.
Okay.
Amen. Hallelujah.
Amen.
Or if you want to find a angle, all you do is that the formula, when you write it, you must make sure that you write the angles at the top. This convention makes it easy for when you are solving. So the angle at the top, now the side is at the bottom.
So the angle should be our numerator.
Yes, and you know what? The one you are looking for at the left, at the top. The one you are looking for at the left, at the top, at the left, at the top, at the left, at the top. The one you are looking for. So that it makes life easy. All you do when you are solving, you just cross multiply. And then the subject you are looking for is isolated. You just cross multiply. The subject you are looking for is isolated. Voila.
Sine A over A is equal to sine B over B. We are looking for an angle with that.
Yeah.
Okay.
Yeah. So when you look at the rule itself, when it is actually written in full, you will actually find that there are 1, 2, and then there's even a third ratio. A, B, C. That is to just accommodate the fact that obviously there are 3 sides and 3 angles in a triangle. But when you are solving a particular question, you use only 2 ratios, 2 fractions, 2 rational fractions, and you solve. Not all 3.
Okay.
Yeah. Okay, so we'll look at a specific example, but I just want to speak that condition of use is very important. It's like, for instance, even with things that you buy from a grocery store, they will write there at the bottom, condition of use. Woe unto you if you don't check out what the conditions of use are. You go and you buy shampoo and you think, Ukwana, it's shampoo for sure. You go and apply it on your head. Can't, it's no hair. Good luck. Yeah. So conditions of use, what you've just said about the condition, you read to me what are the conditions of using the sign rule. So always observe them, because in certain problems will you be able to use this rule. So that's rule number 1. Rule number 2, I don't know how far you guys are when in your school, what you've been taught as far as these rules are concerned. You've done the cosine rule?
No, we've only done the sine rule.
Okay. Then maybe I should stop here and do an example and not expose you to others.
No, why not? I want to be ahead.
All right, no, I'll expose you. I just want to look at one problem where the sign rule is clearly needs to be applied. No questions asked. It's almost as if we could say that we would be doing a disservice and an injustice if we didn't apply that rule. But maybe, hey, look at that. You have people that are like home of distinction tuitions. Hey, there are people who are serious on this platform who are just producing distinctions, leadership. No, I respect, much respect. I don't even know this guy, but I'm sure he's doing the things there.
We have FE.
Yeah, so that is FE.
D. Oh.
Yeah. FED, sorry. Let me just, sorry, that's not supposed to be there. So the actual triangle has, so it's FED, there's 63, there's 41 degrees, there's 2,5.
41 degrees on the,
yeah.
On the degrees,
yeah.
degrees,
Yeah,
and
16 degrees, 41, 2,5.
Okay.
Yeah. So triangle DEF is drawn, all right? Angle E is 41 degrees, angle F is 63 degrees, and EF is 2,5 units. And the question says, calculate the length of DF.
Calculate the length
of DF. Yeah, DF, sorry man, I just made a mistake. There's nothing there with DF.
That's fine.
We want to calculate this length.
So our DF, we can call it the E anish, because it's
we could say it's E. Yes, definitely we could.
So it's our E. So if we want to calculate, we are going to start by saying maybe, I think, is it the length? Oh my god. So we're looking for the length of the F, and then I'm not sure.
Okay, so DF is what we want, all right? It is opposite an angle, which is angle E, which we have. So far I would say that it's good. What we want, we don't have, obviously, but what's opposite what we want, we have an angle. All right, so that will help us set up our fraction if we were to use the sign rule. All right. The fraction on the left, where, as I said, our unknown, what we want, is at the top, at the left. So our unknown will definitely be at the top at the left, right? Yeah, but now we need to check if this fraction, the second one, will we be able to have it given the information we have in the diagram. So we have 2,5 units, but hey, we don't have an angle here. But if we have it, if we had this angle, this would set up our second fraction that's complete, so that we have.
Can't we find the angle using the sum of angles in a triangle?
Oh wow, look at you. Nice. Okay, let's do that. So what am I going to say then?
180 minus 63 minus 40. Is it 41 or 45?
Yeah, 41.
Yes, minus 41. and then that gives us 180 minus 63 minus 41. It's 76.
Equal to 76. What is that? Sorry, what is it that I'm calculating?
It's an angle.
Angle who?
D.
Okay, that's important for me to state. So angle D is equal to 180 minus 63 minus 41 degrees, which is equal to 76. What's the reason we would write in almost in Euclidean? They want us to always write reasons when we state something like that.
It's sum of angles in a triangle.
Okay, so I would have written that obviously as my statement and my reason, and then my answer would have been obviously written after that. But sum of angles in triangle, even though for my trig part of the question, the reason is not really important. It's not something that would warrant me losing marks. But I always say to my learners that please make sure that whether it's trig part or what, if you are doing something that's Euclidean geometry related and it has to have a reason, please write down the reason. Just write down the reason, whether it's trig or Euclidean. Please just have the reason. Okay.
Yes.
Yeah, to validate what you have just calculated. So my man, you've unlocked. Look at that. So we can fill in our diagram 76 degrees. Ish. We are on top of them.
Now we have all the angles.
Yes, now we have all the angles, and especially the angle that will help us. Remember the condition of using the sine rule? A side opposite a given angle. This side that is opposite a given angle will help me with writing completely my second fraction. Then what I want at the top, at the left, is df. Do I have the angle? Ooh, I do. It's 41. So I think I'm ready to write using my sine rule. So I'm going to say what? I'm just going to say df. Now, I know some people will say small letter e. Now, to be honest, if I can be honest with you, Lila, me, I don't really subscribe to writing these small letters and what have you. Me, I deal with the information that's there. So it's df. As long as because this is just to help you understand that it's small letter a, the side opposite the given angle. The side opposite the given angle. This is just trying to emphasize that. But when you actually answer a specific question, remember they're asking calculate the length of df. Don't waste your time and write small letter e, because remember at the end you want to actually get to the answer quick and get over it and move on to the next thing.
Yes.
Okay. So the emphasis is the opposite side, opposite a given angle. The small letter e and all of that, it's just to emphasize the concept. So the meat of the matter is in the emphasis of side opposite given angle. Opposite angle, opposite its side. You see? That's just the emphasis. So we go ahead and say df is equal to sine of 45 degrees.
Isn't it 41?
We also, sorry, my bad. You see me, I'm getting excited and I'm making errors as a result. Thank you. You see, my leader, now I know that I can actually let you fly. You see, when you do that to me, you tell me, isn't it 45 degrees? Then I know I've won a lot with you just in this life. And I'm sure, you see, after the I will fly, my leader. I will fly. Equal. So df over sine 41 degrees is equal to?
2,5 over sine 76.
Exactly. Sense made. Look, the unknown. So this is the whole concept behind making sure when you write for the sine rule, just make life easy for yourself and always make sure that the unknown is at the top, at the left, at the top, at the left, at the top, at the left. Then you can just do cross multiplication.
So is it wrong if I remove the df and put x there?
You remove the
df and I put x.
Okay, why do you want to do that? I'm just curious.
Nah, just because we were just solving. It's
But
just
why?
that.
But why do you want to do that? Because you're gonna waste your time. They want you to calculate the length of DF. Why do you want to hide what you've already got and substitute X? Remember, even with the whole thing of X, boss, X is a variable that stands in the place of something that we do not know. But you are specifically being asked to calculate the length of DF. DF is standing in the place of something that you do not know. So I know that we are obsessed with X because we as teachers have made you guys become obsessed with X. You see?
And for real.
Yeah, we have. And as a result, now you want to throw away something that is already there, that the question is asking you to find because we've made you become obsessed with X. It's like it's like when you know that you need to let go of your X, but you are just holding on.
So can I ask something down there? I see you move the sign 41 because of the cross multiplication, right?
Boom, my liter, yeah. Because
So
this is
what
like me
about
saying multiply both sides by sine 41. Why are we doing that?
initially we want to get the Lontuzan?
DF as a
The
subject
DF.
alone on the
Yes.
left. Yeah.
Oh, okay.
Yeah.
Something is cooking.
Okay. Okay. So I go back to what I said to you. Make sure that the unknown is at the top, at the left, when you write, so that you can just boom, cross multiply. You just cross multiply. There it is. DF is isolated. You put this in your calculator, your answer. Bam. Gone.
So our DF will be we're writing 2,5 sine 41. You close this and then you say sine 70. It's 1,745. Should I round off?
Yes, to two decimal places. Yeah.
It's
After
1,
you so after you punched it in, you said it's 1 comma what?
7,5.
Okay. Then you switch off again and you punch it again just to confirm that your answer is exactly what you're saying it is. So you go repunch it and say 2,5 times sine 41 again over the whole thing is over sine 76. Say equal
2,5 sine 41 sine
76. Ne?
Yeah, it's 1,75. Is it 76 or 70? Oh, 76, not 70.
So it's 1 comma?
It's 69.
1,69.
Yes.
Yay. You see? Because initially, if you remember, you said 1,7 something, I think it was.
Yes, it was because
Yeah.
I said sine 70.
Yeah, you see, and I'm telling you, so there's a document that usually comes out at the end of the year after the grade 12s have written. It's called the diagnostic report. And what the diagnostic report does, it actually documents all the errors after the examiners have marked for the conclusion of a particular year's exams for grade 12s, paper 1 and paper 2. They then write down what are some of the common errors and the mistakes that learners are making, which they observed as they were marking the papers. Do you know what one of the common errors is that learners make a lot? It is exactly what you've just done. They fail to actually write down in their calculator the very same values that they've actually recorded there on the script, and then they get different answers.
Yeah.
Yeah. And then marks get lost. Okay. Carelessly. Because of that. So that's why I said to you, punch it in again, Because I'm telling you, with anything that has to do with the calculator, I would make sure, even as I type in the numbers, you type in, you check in your calculator screen. Hey, is it really 2,5? You type in, you check. You see, you type in, you check. After you are done typing in everything, you check if it's still everything that you actually wrote down. And hopefully, what you wrote down is actually what was in the paper. You did not change numbers. You see?
Yeah.
Yeah. So that there's accuracy here, no doubt.
So let's say now we are looking for what? Okay. They gave us work. Yeah.
We are looking for an angle.
No, we are looking for unknowns in each case. The thing is, I can open camera in this account. But can I spell that for you?
Yeah.
It's like okay, so it's a triangle.
Okay. So it's a triangle.
And then we have our C at the top.
C at the top.
With an angle theta.
Angle?
Theta.
Theta.
And then we have our A at the left corner is A. We have our angle 70 there.
70 here, yeah.
And then we have our angle B. No, our B there.
B here.
And then angle beta.
Angle beta, yes.
And there on the AB, we have our 10.
On AB?
Yes.
You have 10.
Yes. And then on EC, we have X.
On who?
AC.
BC.
AC.
AC, yes.
Yes. We have our X.
Yes.
And then on our CP, we have our 13.
You have what?
13.
13.
Yes.
Okay.
Just like that.
So, and what do they want? Because they've asked us
find the unknowns.
Find all the unknowns.
Yes.
I know that this one is seems like it's doable. There's no other information that has been given to you in the diagram.
No, it's just like that.
Okay, so there's no other additional information. There's no statement, there's no nothing.
Nope.
Okay. No, I just wanted to verify and check that. Okay. Okay. So with what we have here, you can survey the diagram and check for yourself. Is it possible for me to find X first? Now, with the information that we have, is it possible to find X? X is a side. We don't know it. It's opposite beta. We don't know it. So it means X and beta we cannot find yet.
Which means we must find the theta first.
Amen, my leader. Amen. Why? Because we do have a 13, which is a side, and a 70 degrees, which is there, which means my second fraction will be taken care of. And then my first fraction, which will have the unknown angle at the top, we can find because we have the side. So sine rule.
Okay. So if we use the sine rule,
what are we going to do?
I think we're gonna say sine theta.
Amen.
10.
Yes.
Is equals to sine 70 over 13.
Exactly.
And then I think we'll cross multiply.
You see, you are getting it, Baba. You cross multiply. But then we have sine of theta, which is obviously we want the angle theta.
So it's 10 times, so 10 sine 70. Close that, and then we do 13. and then it gives us 0.72.
Wait. Is that a number that goes on with other decimals though? We're not rounding off yet.
Yeah, it's 0.722840.
Okay. So what I usually do with these questions, I isolate theta, the arc of sine.
So I'm gonna say shift sine, and then I put the
Answer.
0.722, whatever. It gives us 46.05.
46,05.
05.
When we round off to two decimal place, right?
Yes.
Okay. There we have it.
Then our next
Then we
angle
have
will be
theta.
our beta. So I think the beta will just find it by the sum of angles in a triangle.
Yeah, born. And then when you have that, you can find x. So I'm not even gonna finish this off. You get the point.
I think I get it. Yes.
Yeah. So now because with this example, I calculated an unknown side for using the sine rule. With this example, it's given me a chance to calculate an unknown angle. And you see, I used the formula when I'm calculating the unknown side with the unknown side in the numerator on the left at the top. But I make sure I use that formula with the sides when I'm dealing with an unknown side. But when I'm dealing with an unknown angle, I need to make sure I use that formula with the unknown angles and take it from there.
Yeah, no, it's valid. This one seems really easier.
Yeah.
For grade 11. Since I've started grade 11, this is the easiest. Yeah.
It's the easiest.
Nah, it's the easiest.
Oh man, that is fun.
The other ones is Devil's Child, is Lucifer on its own.
Yeah, but interestingly enough, like I said, the grade 11 maths is really fun. Honestly speaking, learners that know me will know that I always say to the grade 11s that if there's any grade where you can really like raise your level and your percentage, your performance like nobody's business, it has to be grade 11. You can perform in grade 11 in a way that you've never performed in the history of your maths performance. Yeah, and currently what I am loving as well is that the learners that have been walking the journey with me are learners that are reporting to me are getting 90s, getting so and so, especially the ones that, like I said, have been walking with me in the platform and so forth. The grade 11s, they are doing the things, my leader. I'm happy. I'm pleased with their performance. Most of them only got their reports when schools opened. Yeah, with the return, and I've been getting reports left, right, and center. I had two this week report to me. Like one was saying, so I got 94 overall term 2, and then the other one was like, I got 90 something. And then the other one was saying, the one I was telling you about, that said, I got 100. And I said, like, that's nice. And I was like, now you need to maintain that 100, because above and beyond maintaining the 100 most, you want to maintain the overall performance for all your other subjects as well. And he was like, yes, definitely. I was like, yeah. And I think that boy, that day when he goes to the podium and he does the things, no, me, I'll have to make my appearance there, because that one. He's doing podium stuff.
Let's hope I'll also come with the good marks.
No, you must do it, my lady. You must. You owe it to yourself. Remember, like I said, you owe it to yourself as far as making sure you are able to solidify a place at an institution of higher learning come next year. So you owe it to yourself. And just making sure that there's no, I don't know, it doesn't have to be an issue of, hey, he can't do this course because, no, it has to be a matter of, no, it can't be the marks situation. It has to be something else that has nothing to do with performance.
Marks.
Yeah, so do that for yourself.
So you go live every day, or you have like specific days where you go live?
Yeah, so I go live. I try go live every day. So for instance, I'll be like, I wasn't able to go live. I think yesterday I didn't go live yesterday. I couldn't. I actually mentioned that I couldn't. But yeah, today I said I would come. I would definitely go live. So I did. Tomorrow I'll go live again. I'll be going live again. And like I said, it's usually between sometimes 8
and 9.
Depending on a good day, 8. But 9 if it's not panning out so well at 8 o'clock.
Nah, I'll check between those times.
Sure, my lady, sure. Otherwise, it was good. It was good having you. I commend you for your courage, for actually, I don't know, requesting when I don't know where you got the courage to request, but yeah.
Nah, I'm also thankful for the help I've received today.
No, you are very welcome. Like it was very good. You must say to your sister, you actually owe your sister as well, eh?
Yeah, I really do. Because if it wasn't for her, then I wouldn't have been here.
Yeah, no. All right.
Thank you.
Have a good one.
Thank you.
Yes. Okay. All right. That was lit. Really appreciated that. That was good. Guys, do go and check out the channel of the YouTube. I know, I actually I think someone actually like took the time to give me a critique when it comes to the YouTube videos. Yes, guys, I know. We could improve the quality of those videos. But the thing is, remember, I just simply upload the live lessons as you see them, as raw as they are. I guess that's my signature style, if you want to call it like that. I see that the views of the videos are not that high and stuff, and I guess that's not the point. Yeah, but yeah, I know we can better situations, and we will with time. But like, for instance, if you want to check out, there's a two-part lesson, live lessons that I've done on area, sine, and cosine rule. So you can check it out on the YouTube channel. There's a playlist that I uploaded of 2 videos. The first video is like an introduction to the sine rule and area rule, cosine rule, and also the conditions of use for the different rules, and just like your basic problems. Part 2 of the live lesson is where I actually went in deep into like more problems that have to do with the sine rule, area rule, and cosine rule, but also I delve into like your variable type problems, where you have your theta and your beta, but also with your more complex diagrams. Sometimes, and what I mean by complex diagrams, guys, I mean this. Okay, the username of the YouTube link is in my bio, guys. All right, and if you can't access the YouTube link simply like by clicking on it, please you can copy and paste the link onto your search engine for Google, and then go and search it there. It should be able to lead you there, right? So for instance, I did these types of questions, these types of problems where you are supposed to find the length of BC in terms of your alpha, beta, and theta, but it's after exploring all the rules, the sine rule, the area rule, the cosine rule. So for in those videos, part 1, I actually go through all the rules, area rule, sine rule, and cosine rule, and then I do individual well, actually, I don't think I go deep into doing the individual problems for cosine, area, and sine rule, or do I in part 1? But just check it out. Part 2, that's where I go into like more problems on sine rule, area rule, and cosine rule. through those problems, I explain the rules and the conditions of use, and then I actually answer these two questions. This question I answer there because I need to find the length of BC, which is finding the length of BC. And I actually explore a method on how to tackle these kinds of questions, because there's really a method that makes it so easy, of like questions that you ask yourselves that lead you towards actually finding the length of an unknown. So please check those out. All right. And let us play the maths game, because the channel is Maths is a Game, and it's definitely about making sure that we are able to do the maths, play it and play it well, and get the level 7s and the distinctions. They come really and truly as a direct result of that labor. But thank you so much. It was great, and thank you for those that joined in. It's always a pleasure, guys. It's 12 o'clock midnight. Like really, I'm up. Thank you, guys. Have a good one, and cheers, and thanks for joining.